Buenas tardes a todos.
Good afternoon. Welcome to Espacio Fundación Telefónica and to our event about art and artificial intelligence. This afternoon, this evening, we have a group of professionals with us directly linked to art and artificial intelligence. For many years, artists have worked together with machines, to create art. In the 70s, the artist Harold Cohen created an IT software called Aaron, and Aaron created artworks such as these and this one. Cohen gave instructions to Aaron about how to represent perspective in art, how to draw a human body or flowers or plants. But Aaron was not creative, nor independent or autonomous. He could not produce its own art, because each new artistic skill of Aaron was programmed in the machine by Cohen. But now, artists have gone beyond these limits. Artists can now train machines so that machines can create their own art. Artists train or feed and scan art images in the machine, not to make it follow instructions, such as Aaron did, but so that the machine learns to create its own art. So the artist does not give any instruction to the machine. It only the artist shows images to the machine, and the machine draws its own conclusions. We can say that in this sense, the artist and the machine are collaborators in the process. This evening, you will hear a lot about machine learning. There are many people that say that the art of artificial intelligence is the next big art movement. We have 3 speakers today. They will speak for about 20 minutes, and after all our presentations, we'll open the floor for questions for about 20 minutes. Our first speaker is Jake Elwes. He's an English artist that works with artificial intelligence. He will present the topic and step by step will guide us through the process of machine learning. Jake is a graduate in fine arts by the Slade School of Fine Arts in London. He has exhibited in both in the UK and abroad in exhibitions in the Victoria and Albert Museum in London, the Baltic Centre for Contemporary Art, also in London, the Cyphers Festival in Venice, the Ars Electronica Festival in Linz, Austria, and the Naturmort Gallery in India, among many others.
And I'd now like to invite you to speak. Thank you.
Thank you. I think there's this one.
Okay.
Well, thank you for that introduction, Anna. And I love seeing a reference to Harold Cohen as well, who was actually at the same art school that I was at, probably over half a century ago. So, yes, my name's Jake. I'm an artist working with these technologies at the moment. I apologize for speaking in English. I don't speak Spanish, I'm afraid. This background is completely removed from AI or anything digitally produced, but it's in fact circuitry which I've put through an old printing press, an etching press from my old art school, which had these wonderful Victorian printing presses. So, does this work? I'll do it with this. So first off, I would like to talk about what we actually mean when we use the term artificial intelligence. And why is it interesting for an artist in the first place? I think the term artificial intelligence is actually a bit of a non-term. it doesn't really mean anything. It's a really large field, which is very tied up with all sorts of ethical and political parts, philosophical sections, and the technical as well, which is what I'm really interested in. What I'm really talking about is machine learning. And machine learning is the tools that we have to make computers learn from data sets, vast amounts of data which we feed it. Is that now working? Super. So machine learning this here is a diagram of what's called a neural network. And when we talk about machine learning, we're talking about feeding a computer algorithm vast amounts of data. And this could be data of any kind. That could be sound, audio, it could be text, or it could be images. Images is what specifically interests me at the moment, and this whole field of computer vision. So deep learning is a step on from machine learning. When we talk about deep learning, we're talking about, again, using neural networks in a far more unsupervised way. So they are learning autonomously from the humans and us labeling these data sets. So again, I'm going to say I'm not really a scientist. I'm actually an artist. So this isn't sort of technically rigorous. This is me coming from the background of an artist, and this is what I got really excited by over the last 5 years. I went to quite a traditional art school, which was very critically rigorous and traditional, and I was the only person coding there, so I was down in the basement and trying to explain these technologies to my peers and how exciting they were. So this image up here is a neural network. A neural network is very, very loosely based on how the brain works. I wouldn't extend that metaphor too far, because it's only really connected to the brain in the sense that you have neurons and connections, which are kind of like synapses in the brain. What you do is you feed data through it, and it works out all of these weights, and it goes through all of these connections, and it uses actually really quite simple mathematical functions, which kind of go back and forth until it can get really, really good at performing a very specific task. And that task, for instance, might be looking at images and saying which of these are images of cars. That's an example of a machine learning algorithm. So this really, really interested me. Once a machine, so this field is called computer vision, right? It can learn how to detect images of cars or images of trees or images of whatever you feed into it. And we feed in photographs of, let's say, 14 million photographs, which is a standard data set, ImageNet, used by governments and academic institutions. And once it's learnt to recognize these trees and these cars and these cats, what it does, which I think is quite extraordinary, is it plots it in what's called a latent space. I like to think of this spatially. If you imagine all of the cats and all of the features and all of the things that has detected the kind of cattiness of cats, or all of the treeness of trees, looking at the leaves and looking at the branches, it might plot all the cats down here, all the trees up here. We can't actually visualize this space, because the way that the mathematical algorithm understands these images, it scans across this image and it gives it 100 numbers that correspond to that single image, and it will plot that in this space. So this space isn't two-dimensional or three-dimensional like this diagram, it's multi-dimensional. So we can't visualize it in our, physically in this world, but this idea of this hyperdimensional space, and you can move around it. And I think it's quite a beautiful concept in a way. So all the features it has learned, all the data exists in this space. The data set doesn't actually exist anymore, only the features that it has learned. So when you give it a new image, it will understand how to comprehend that image by where it fits it into this space and what it has learned. It can see eyes, so it thinks it's probably a human. It can see a wheel, so it thinks it's probably a car. We can visualize these spaces. This is what's called a t-SNE. And you can see it's starting to I think these are all computers and machines up here. It starts to see, I think see pen knives, trees, grass over there. I think this is all water sports and boats. So this is ImageNet, the data set that I was talking about, that has been plotted in 2 dimensions down from this 100-dimensional space or 512-dimensional space. Now we can just understand it with all of, seeing them next to each other. And it starts to, you can see here, this is quite interesting, it starts to see all of the circular objects next to each other. So what happens if you take all of the artworks from the largest museum collections in the world and plot them in a space like this? And this is what Google Chrome, there's a Chrome experiment which does exactly this, called Freefall. I want to quickly see if I can show it. Here we go. So here is running on the internet a collection, the largest art collection, Google Culture's art collection from, I think, 10 art museums around the world. And it's plotted them spatially from what it understands and sees in them visually. So it doesn't really understand the context in which that art was created. We can see this lovely way of seeing it as well. So it might have plotted all of the sketches next to each other, all of the portraitures, but it goes beyond that. It starts to understand abstract features in these images. It might start plotting all of the crucifixes next to each other. You can kind of see what this does. So another extension of this is when you have this latent space, and let's say you have a Leonardo da Vinci image here and a Mondrian image here, it will understand those as points in space. What you can do is you can look at the journey to get from one image to the other image and where that passes through. And this is what an artist, Mario Klingemann, has done, also in collaboration with Google. So like I said, we can say, what happens if we click on Mondrian and let's go to Hokusai. So to get from a Mondrian to a Hokusai, it will take us through this path in later space. And you can see very clearly it's understood the visual context of the image. I wouldn't say it's understood much more. That's the thing. I think that's a much larger question. At the moment, these algorithms are stupid. They're dumb. They're just looking at the visual content, and they do very specific tasks. It hasn't understood the context in which that art was created, which I think is an important point. OK, so moving on from that, moving on from how an artificial intelligence algorithm learns to see the world and learns to plot these images in a space, I got really excited by this, which was about 5 years ago. This new architecture came out, which is called a GAN, a generative adversarial network. And the premise is quite simple. It asks, how could an AI fake a new image to fit into a data set? So let's say you train it on images of flowers. Then what you have is you have a new network. You have 2 networks which are fighting against each other. So this discriminator here is it learns to classify images. So it gets really good at saying this is a picture of a flower, right? Like I said before, one that learned, say, these are all pictures of cars or cats or trees. So what you then have is you put a generator network against that, which starts with nothing, with random noise, and it goes through iteration and iteration to try and create the most realistic image that can trick the discriminator into thinking this is a real new image of a flower. But it's not a real image of a flower. It's an imagined image of a flower from the computer's perspective, from everything it has learned from all of the other images, but it's not a real photograph. And they can look extraordinarily realistic. So this is the most state-of-the-art example of fake images. None of these images are real. These aren't real photographs. These are all generated. So like that bubble, I mean, it's extraordinary. You know, it's looking for features in these images. It learns from these images, and then it can recreate these images. And it can trick us into thinking these are real photographs, but they're not. So, I mean, you might be able to see kind of in the wolf's face that it doesn't quite look real, the dog's fur, but it's really very good. This is Google DeepMind released this paper about 6 months ago, so this is the kind of state of the art. And it's also quite high resolution, which is, you know, 5 years ago you could only do this with images which are absolutely tiny. So this is where we're at now. Now, about 3 years ago, I first discovered that these algorithms existed. And it really excited me as an artist from a philosophical perspective, because, you know, it calls into question creativity, really. Like, what is art? What's producing an image? I mean, I wouldn't say these are interesting or creative, particularly. I think this is, you know, trying to mimic images in a data set. I wouldn't call that creative. But paired with an artist and trying to get it to do something more poetic and conceptual, I thought there was a lot of potential here. So the first piece that I did was a collaboration with an artist called Roland Arnold. It's in reference to Nam-June Paik's TV Buddha. It's the famous seminal piece of video art where the Buddha is staring at itself in a CCTV feed in a constant feedback loop. So what we did is we gathered images of the Buddha, and we thought it would be interesting to have a Buddha staring at the computer try to create an artificial image of the Buddha. And what it created was this. I mean, an engineer would say this failed. It failed to produce realistic images of the Buddha. But from our perspective, this was fascinating. They kind of look like Rothko paintings or something. I mean, it's very primitive, but I mean, the reason that you don't see the Buddha in this is actually because we didn't have enough data. We didn't feed it on enough images of the Buddha. We didn't have enough computing power. You know, sometimes you need to train these things for weeks and weeks to get really good at recognizing images and then get really good at creating new images that can trick the classifier. So this was our first instance, and we put it up against the screen, had the Buddha watching its own reflection, watching a computer fail to create a realistic representation of the Buddha. The next piece that I want to talk about is, this is an experiment I created, when was it, 2017. This is quite primitive and low resolution by today's standards. I call this latent space. So what would happen if you're no longer trying to get this generator to create really realistic images of trees or cats or whatever it is? What happens instead if you just get it to move around this latent space aimlessly? So I gave it random vectors, positions, which were 500 numbers, which corresponds to this space, and it would just move around, and it wouldn't be trying to find anything particular. It would just be kind of dreaming through this space. And this is what it created. And that was really exciting for me as an artist to see how painterly this was, and how it had also kind of learnt, you know, really low-level features of photographs. And, you know, photography, which represents us and our creative expression, you know, it kind of learns the rules of thirds. Sometimes you see horizons in it. It's very painterly. So I presented this kind of on the scale of an abstract painting, of up for large. Sorry, that sounded terrible. Obviously, my dad's a painter. I move away from painting. But I did show this to certain curators who were kind of appalled by this, because they thought that, you know, it's such a human thing to paint, the creative impulse, and to see a computer which had been trained on images in maybe a slightly similar way to how we're trained and conditioned by images we see from birth, and it starts to generate images outside and beyond the images it's been trained on. Of course, the computer here didn't have any intention Like, it was me setting it up. So in that way, it's definitely still a collaboration between me, the artist, and the algorithm, because it would have no reason to want to create these images. And of course, there's also a history of that in conceptual art and systems art. So you look at Duchamp and Cage, and using randomness in art, Sol LeWitt. You know, there's definitely a history of that we can follow. This is just going a stage further because I don't really know what it's going to produce at all. I can open up this neural network and look at the weights and not really understand how the algorithm has come to the conclusions it's come to. I don't fully understand how it's learned to recognize the eye of a cat. This is a project that I'm working on at the moment, but these faces are all fake. None of these are real people. And you can kind of see some of them are quite weird, like, you know, it doesn't quite get the eyes right. So this is a state-of-the-art model for generating faces called StyleGAN. I'm very struck by, you know, I mean, there are so many political and ethical questions as well, which I think it's important for artists to be thinking about and addressing in this field, because it's a huge field that's going to affect all of our lives, how these algorithms are being used. And being able to generate images from this is important, because this data set is a standard data set. Well, there are a couple, but Celeb A is a standard one that's used, which is a data set of faces, mostly Western, celebrities, so that they can get around copyright. And it's used for facial recognition software by governments, right? But it's almost all white Western faces, which is really interesting. It picks up biases in that data set. So we train it on a lot of Western faces. Did anyone see the Face app thing on the phone? So there was like an app on the phone where you can take a photograph of yourself and tell it to make you older, tell it to make you younger, tell it to make you more beautiful. The more beautiful vector was quite controversial because it made people of different ethnicities, it made their skin lighter because it thought that was a sort of Western beauty standard, which it learned from these data sets. So I'm quite interested in sort of injecting more diversity and corrupting these data sets. So I hang around a lot with drag queens and the queer community in London. So I've been training it on images of drag queens, and it's, I mean, this is something that's literally training at the end of my bed at the moment. But yeah, I guess this idea of kind of corrupting the status quo and pointing out that they're not diverse. They're quite demonic, some of them. I'm not quite sure if that was what I was after. And I haven't quite worked out what to do with these images yet. But you can see that some of them are really quite bizarre. Sort of third eyes and things. Anyway. This here, who's heard of deep fakes? Have you heard of deep fake? So the idea here, have we got sound actually? Might go back a bit.
Charged more just for being a woman.
This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. That's a time when we need to rely on trusted news sources.
So there, what you're seeing is an actor acting for Obama, and you can get him to say whatever you want. I mean, this is obviously incredibly politically charged and terrifying. It's already a couple of years old, so this has got even more believable and realistic. Again, it's the same sort of concept that you have. So this is, you know, trained on many faces, and then you can stretch this vector and say, you know, there's one vector in this space which kind of corresponds to the eyebrowiness, and you can sort of change the eyebrowiness, or, you know, change the gender, change the race, whatever it is. With Obama, they're literally using it to remodel his face and get him to say whatever they want him to say. There's a more comic example of this too. This is doing the same with pose. So this is the input. This is the training set. And then these people are dancing in the style of the ballerina. I like the fact it's just two researchers from Berkeley that are... So we've spoken about faces, we've spoken about images. I'd like to quickly speak about a couple of other sorts of data sets that you can train on, which have so much creative possibility. And I think all of these things, as an artist exploring this field, there's just so much fruit ripe for the picking. Researchers are releasing papers all the time. And this is another interesting thing, which I think we're going to maybe get to later, is obviously intellectual property and how you can credit the researchers that have worked on these algorithms that we're using. Because, no artist really, maybe with a couple of exceptions, can understand the technology at a deep enough level to be able to write all of this code themselves from scratch. But, what I do with this is I kind of hack on top of it, and I understand the code enough that I can write my own new code that I can kind of inject into it to create something that the original algorithm wasn't intended to do. Something that I find more exciting or poetic. So here, yes, sound, WaveNet. Google released WaveNet. Generating sound from scratch, from nothingness. So getting a computer to create sound that knows nothing about, how acoustics work in the real world. All they understand is samples. Is a really, really big problem. And I think, images, it's slightly more understandable problem for computer. You can, feed a neural network with the pixels. You've got a finite number of pixels, and it can start to learn what an image is and how to understand the world visually. With sound, you have 16,000 samples a second, which creates audio waves, and that's got to relate temporally to everything that came before it. Sandra Dieberman at DeepMind created this algorithm and trained it on classical piano, 60 hours of classical piano. And this is the result he got. So this is an algorithm that knows nothing about acoustics, timbre, how the piano works, musical structure. It's literally just generating waves, raw waves. And this is what it created. There you go. Someone else also, I think, called Dada Bots, trained it on the Beatles. So you get quite... I think things have maybe moved on a bit from here. This is a slightly old example now, but I find it quite funny. Language. Again, you can do the same thing. So this latent space, if you carry on imagining this space, I think it's such a philosophically rich concept of how a computer can understand the world. And I think maybe there's something of Wittgenstein in there as well. But if you can plot the whole of the English language, or any language, but this is done in English, if you can plot this in this space, in this multidimensional space, it understands the meanings, the linguistic meaning of words in this space, which is a really extraordinary thing to wrap your head around. So this is trained on news articles and on Wikipedia, and it says which words are commonly found next to each other, and it starts to understand the content and context of those words and how we use language. So what you can do is you can say Madrid is to Spain what London is to the UK, right? And that has like a mathematical algorithm. You can say, okay, literally the space here, and if you then subtract that one and move it across to Spain, then it will come up with Madrid. It kind of understands that as a spatial thing. What you can do is you can, so Memo Atkin, who's a wonderful machine learning researcher, he did this, and he found some really playful things. So if you do human and minus God, you arrive at the word animal in this space. That's the word that comes up in this multidimensional space. Science plus God, metaphysics. He also did the same to point out gender bias, which I think is really fascinating. Although the machine itself isn't biased, it's the data. The data that we feed in is biased, but also our interpretation of the words is biased, because how can a machine be biased? it's just ones and zeros. It's just stupid. It's what we take from it. But it was a fascinating demonstration of what you can do with this. So if you do man to the word organization and then woman to the equivalent space, it comes up with the synonyms of advocacy, group, association, charity. If you do woman to organization and then man to the equivalent group, it comes up with group, team, association, club. So yeah, no, that's a really exciting example. This is quite fun. So you can do something with machine learning and language where it's what's called a recurrent neural network, and it learns from being trained on huge corpuses of text what the probability that the next letter will be an A or a B or a C is. It doesn't understand anything about grammar. It doesn't have a dictionary. It's just literally on the probability from everything it's seen before in examples of text of what the next letter will be. And what's quite fun is that you can train that on different writers. So this is someone who's trained it on Ernest Hemingway. Sorry, where's my mouse gone? There we go. And what we can do is write something. There we go. One small step for man and the dead grand, the doctor something. If I say I don't really like that, it will probably generate us another one. Oh, there we go. It's generating more and more text, but in the style of that writer. So again, huge potential for like creative. Oh yeah, we're running out of time. Okay, I'm going to speed through a little bit because I've still got a few slides. Briefly wanted to say, AlphaGo, this is kind of the next step from everything I've been talking about. I've been talking about deep learning. Google Mind in London have been working on deep reinforcement learning algorithms, and they beat the champion of Go, which is a vastly complex game, exponentially more complex than chess. And the way that they did it, because people said it couldn't really be done, you can't explicitly teach a machine the rules of Go, this game. So it played itself against itself billions and billions of times until it learned the rules itself. And then you can apply that sort of algorithm to many, many fields. And they're applying it to healthcare and all sorts of different game scenarios. This is a kind of step towards artificial general intelligence, which I'm not really going to talk about because that gets pretty crazy. And okay, we're really running out of time. Okay, so I'm just wondering where to leave it. I was just going to show two of my artworks very quickly. So this is a piece that I made called Closed Loop, which is basically two AIs which are having a conversation with each other. So what this is an image generating network and another network which gets really good at writing sentences about what it sees in images, right? So what it's doing here is it's generating an image of a large piece of paper, and then when it settles on something, it will say what it now sees. So now it's seeing a bird flying in the air, right? And then it will go back and try and generate a new image of a bird flying in the air. And it's this sort of constant feedback loop. What else did it go through? I think we kind of go through blankets. It sees all sorts of unexpected things, which I wouldn't have seen myself. I probably don't have time to talk about this piece, but I was generating many birds from the marsh, which is the place I've been going since I was a child. I took them out into the mud. The birds interacting with the artificial birds. The sound is also generated from sound recordings of birds. And I think I'll leave it there. But thank you very much. Cool.
Thank you, Jake. That was fascinating. Mun-Jung Chang is
Mun-Jung Chang is our next speaker. She's the head of art projects in Onkaos. headquartered here in Madrid. Onkaos, in my opinion, is the sponsor and the leader, sponsor and promoter at world level with regards to artists working in the AI field. They represent pioneers in this field. It is Mario Klingemann, to whom we usually refer as the godfather of AI art. Before joining Onkaos, Mun-Jung has worked for almost 10 years in Ivory Press here in Madrid. She was an exhibition coordinator, and she has coordinated multiple exhibitions regarding very famous artists such as Cornelia Parker and Nam-June Paik, Yves Berger, Edmond de Waal. She will speak today about Mario Klingemann's work and the role of Onkaos in sponsoring artists at work with AI.
Thank you, Anna, and thank Jake for amazing speech. Muy buenas tardes a todos.
Good evening. I'll be speaking in Spanish. I learned Spanish 2 months ago. No, it's not true. You concede. I'll start by thanking, of course, Anna O'Connell, President of ADA. Thank you for your fighting spirit, your support. I would like to thank Fundación Telefónica for welcoming us here in this huge building. And I would like to thank you all for being here with us today in order to talk about art and AI. My name is Mun-Jung, as you know, as you can see here. And I'm lucky enough to have the best job in the world, which is working for Onkaos. I'm going to share my experience with you, our project. In Onkaos, in our project, we believe in our artists. We believe in artists that work with new technologies. Among others, we work with Margot Silverberg or Mario Klingemann. I will talk about him in a while. We're very curious. We like to work with curious people, curious artists, artists that are able to surprise us. But above all, with artists that can take us to places we've never been before from an emotional point of view. Onkaos is a reality due to 2 factors. First of all, the solo collection. It's a private collection, an international collection. Museum is located here in Plaza de la Independencia. You're all invited to visit this place with its collection, led by Ana Gervas and David Cantoya, 2 people I love. Because I truly believe that, particularly in Spain, we need passion, but it's not enough. Passion is not enough. It's so important to fight for our contemporary artists. We should not wait for public institutions. The support, even though it may seem little, but it gets bigger, it grows little by little. And I would like to congratulate Colección Solo on that account. And in the different projects, they always support and sponsor contemporary artists. Their collection is made up of more than 600 artworks, artists from 175 countries, such as Betty Bong, among many others, and the Taiwanese artists which are currently exhibiting in our collection. They are all part of our dear collection. We have 2 interesting programs. One is Solo House in Madrid and then Solo House in Como, Cantabria. The second factor, which in our opinion is interesting and innovating, is new technologies. They belong to the history of art. But I'll give you an example. Photography, the case of photography. It's a metaphor I use because photography was born as a science, was a technique. But it's true that the impact of a synthetic image as a science was turned into an art expression. And it's a similar situation to the Onkaos. Onkaos believes in artists that work with new technologies and AI, and we consider that this is art. Here, on the left, we see an image of a woman, a lady. It looks that it was taken in the 1930s, daguerreotype technique, and then we have a Georgia O'Keeffe image taken by Alfred Stieglitz. Over his 50 years of professional career, he fought to prove that photography was art. I'm going to speak about Onkaos activities. Onkaos supports its artists as if they were our children. We truly love them. We support them 24/7. Everything they do, we're with them. But I would say that Mario is the most successful case. Mario Klingemann is a German artist. He lives and works in Munich, 49 years old, a very important career. He was previously known in the field of AI. He's a great pioneer. But it's true that its work is present in many important institutions such as New York's MoMA, Pompidou Center, Barbican Center. And I'm going to take advantage of this opportunity that today in Russia, in the Hermitage Museum, Mario Klingemann's exhibition is being opened, and our manager, instead of being in Russia, is with us. So a big round of applause because I'm very happy to tell you that since last Friday, he's been appointed digital culture advisor for Fundación Telefónica. So a big round of applause. So how do we support our artists, Mario in this case? We help them to conceptualize the work, to produce it. Production is an interesting topic. It's based on a trial and error system. In new technologies, as you know, machines function at a very high speed. Of course, financing, we finance the work, distribution, marketing, because these works are marketed. We believe in sustainable products and also the legal side of it. We help them to talk to institutions, museums, centers that may be interested in purchasing Mario's works, or copyright, which I think it will be addressed later by Alexandra. I'm going to speak about 4 projects, Mario's project, so that we can understand his development and how we supported our artists. The series called Imposture Series dates back to 2017. We have 3 images here. The one in the middle is called Patch of Sound. It was a work that received an award by the Lumen Prize in 2018. It's made of 6 prints, single edition. And here the machine created and he painted. What the artist wanted to do was surprising the audience. This project is a performance, 3 days in Sonar Festival in Barcelona in 2017. It was the first wall designed by the artificial neural network. The question here was, is it possible for a muse to be artificial? Or, on the other hand, do we need a physical muse, a human muse? So, everything's okay. up to this point in time, he used to work in physical media, such as paper, among many others. He worked with Catalan artist Albert Break, among others. But we are ambitious. We like challenges. We don't like when someone says no. And the big challenge was, is it truly possible to pass this print through the machine, through the algorithms? Is it possible to collect algorithms that they're part of our exhibitions, our museums, our daily life? And I think the answer is yes. We're saying it. That's why I'm going to share with you two projects. Memories of Passerby 1 from 2018. What you're seeing on the screen is two vertical screens. On the left, we'll always have men. On the right-hand side, always women. I don't know if you can see it here, but here is the autonomous machine. I think it's better if the artist explains the project. So we're going to see the first video, which was prepared especially for you.
Piano, would you ever ask, is the piano the artist? No. So same thing here. Just because it's a complicated mechanism, it doesn't change the roles. Memories of Passers-by is a machine that I created that will keep on generating portraits of non-existing people forever. And it can do that because it uses a collection of neural networks. And in this case, I used portraits painted by the great masters from Western European art history. And yes, so now the machine is in this in a cycle where it continuously creates new faces that start changing, that fade away, and it observes itself and creates a feedback loop. It's not a rendered video or a curated print or curated images that I pre-selected. It is doing it at that moment, which is a risky thing because it's a system where you have only a certain amount of foresight what it might do. The piece consists of two screens, of which one will show more female-looking portraits and the other one more male-looking portraits. And then there is a case which was kind of custom made for this purpose because the computer will not mind that is inside, because that is, of course, it houses a very powerful machine which creates those paintings while you look at them. So I think that's quite magical. Typewriter enables somebody to write a book. For me, well, the keyboard enables me to write code. And then, well, yes, then there are neural networks involved, but maybe you could say they are my brushes that I learn to use. And but in the end, it's always this feedback between me, the artist, and the medium and the material, and is at least like a child that I can say, okay, now you go out in the world alone, and I can trust that you will keep on doing what I hoped you would do for, even if I'm not sitting next and am still able to change something. So So that is kind of like a hard moment for me to say like, okay, now I believe it's okay to take my hands off the keyboard and let it out in the world. Working with neural networks, in these days, it is actually not so easy to create an image this big. And this is 4K. It took me quite some research and different attempts to actually get it to work at this speed, like at real time and at this size. And well, yeah, not to be bragging, but I don't know many others at this point of time who can do the same. I definitely want to explore the space of portraits more, but on the other hand, I'm also not limited to that. Also want to explore other forms of media or other forms of presentation, so I'm looking forward to what I will be able to come up with next. And I think in these ages where, like, yeah, we have so much information is coming down onto us, like where you can save everything and you can undo and you can copy paste, but no, this thing does not allow that. You have to be there, and yeah, I think when you sit with it, then and watch it for a while, well, I hope that people can start appreciating this or get this feeling that I get when I watch it.
Yo de verdad que cada vez que veo...
Every time I watch his artwork, I'm touched, because it's amazing watching an artwork that it is alive. You're never going to see the same image. It works 24/7. It's amazing that someone such as Mario, an artist has created such an artwork. So let's focus. In order to better explain the role of Onkaos and how we supported our artists throughout this time, as I've said before, well, I don't know if I said it actually, but the edition of Memories of Passerby 1 is made up of 3 parts. The first one was sold in Solo and the second in Sotheby's. As you know, it was sold in Sotheby's last March. It was an auction. It started at £40,000. The selling price was £40,000, and over those intense months, 8 months of intense work, all the activities related to promoting and advertising its work, Mario's work, was incredible. But there was more. The auction was stopped at £40,000, but the impact Mario had at international level was huge. Not only in big papers, magazines such as Bloomberg, The Arte, but it's true that Mario was already a known artist, but the requests we have, requests for prices, they request us to loan Mario's artworks. These are the consequences. His has 5 exhibitions in a month, and this is amazing. The next artwork I'll present is Secret Training. This project was presented last month in the Barbican Center. I'm going to share the video we've prepared for you.
have machines in order to take over work from us that we don't want to do ourselves in order to save us time. Then what do we do with all the time we have saved? Because we can't store this time. We have to spend it. We have to waste it. My answer to the question, what is it the machines want from us? What is their motivation? And well, my answer is yes, they want us to spend time with them. They want us to spend their time on them. Circuit training is a machine that tries to steal as much of that time people have to spend as possible and accumulate that. And it tries that by getting your attention. Initially, the machine doesn't know anything about what humans are interested in. What kind of images do we want? So it has to learn those. The learning process is part of the entire installation. So the first section is the data acquisition part. So it is a photo studio where people can volunteer to have themselves scanned by the machine. It takes their portraits, but it also scans the entire body because like what we wear, like the fashion we wear, maybe interesting colors, patterns, the shoes, this all contains different sorts of data. So I added a screen which tries to give you an overview of all the different areas, well, how it analyzes your data, what it does with it. There's also, of course, the whole statistics of the other data it has acquired, which happens in stage 2 of circuit training. So, in order to know what it is that humans find interesting, it needs the human feedback. So the voting booth consists out of 4 little tablets. If you volunteer, you are presented with an image and then you have to decide if you like it or not. Each model has a certain aesthetic, but then I chain them together, like not the algorithm randomly picks several models, builds a pipeline out of it, and then produces images. In some sense, the same technique that I show here is something I use to train models, to decide, to train for other artworks I create. It's possible that it created an image which, where it's close to something that hasn't got any votes yet, where it's indifferent, but this image might look very different to something it has created before. That's kind of the novelty check. So if an image is indifferent but looks different enough, like new to the machine, it will also present it as a vote. And there's the hope that eventually goes into places where it creates interesting aesthetics or stuff that, well, even I didn't expect. And hopefully it sometimes even shows you something that you didn't expect and that you still like. The final step is, of course, the one where the machine accumulates actual attention. But what it also does, there's another camera on top of the projection which watches the audience. And the more people are engaging with the image, well, looking at it, the more it accumulates their attention. It will include that in its learning process, in its generation process. So in this feedback loop, I'm hoping that over time, well, some kind of direction or several directions that are promising, that actually give the machine what it wants. So as you can see, this installation contains of a lot of different moving parts, a lot of technology, and I was really happy that Onkaos supported me in making it happen. So when you watch the output of the machine, you will notice that not everything it shows you is, well, beautiful or actually interesting. But that is the point, I think. It is learning, it's trying to be interesting. I mean, it's almost like a performance where this, and it's a long-term piece. So right now it's like a 2-year-old or something like that. It's alive.
Bueno, maravillosos vídeos.
Well, the videos were wonderful, and they were made by our audiovisual team. As Maria said, his artworks are alive. It's like a 2-year-old kid. And I would like to finish my presentation by saying how thrilled we are, by how thrilled we should all be when sharing and starting this new era. I don't have the answer to the question where we're going. I can just say that we are trying, we're exploring, we dare. Technology goes hand in hand with art. So I think we're going to get to very interesting fields. And we have to wait and see. This is the start of a new era. But last but not least, I would like to raise another issue, which is digital preservation. Very recently, we had our chief curator, Ms. Betancourt, in the Preservation Institute of Connecticut. And since new technologies and machines are constantly evolving, we wondered how we could continue to develop while supporting new creations. Thank you very much for your attention.
Muchísimas gracias, Mun-Jung.
Thank you very much, Mun-Jung. It was great. It was impressive. Our last speaker is Alexandra Pygall. She's a lawyer and partner of international law firm Stephenson Harwood in London. She's a specialist in intellectual property. Her work covers a wide range of issues related to intellectual property, such as copyrights, brand design, and patents. And a few years ago, she was named one of the top 100 lawyers in London, thanks to her innovative work of the past year. So thank you very much, Alexandra, for being here.
Thank you for inviting me to speak this evening. I'm conscious I'm probably speaking to an audience of experts, so you're going to have to bear with me because all I know about is the law. And unfortunately, the law doesn't have all the answers, which is the other problem I'm going to struggle with this evening. But I'm going to do my best to give you a snapshot of the types of issues that lawyers are grappling with in this area of art. The other issue we have to grapple with as lawyers is that the law is not the same in all the countries around the world. And so that also I don't have all the answers to this evening. When I started to prepare this presentation, I thought I'd be done in a couple of minutes. And the more I read and the more I learned and the more I learned from colleagues who've spoken before me this evening, I realized there is a lot to talk about. I also realized that I'm standing as a lawyer between you and drinks, and I realize that this is not a popular place to be. So I'm going to try and just give you a flavor this evening of some of the issues that lawyers are grappling with, and hopefully we can talk about it more over drinks afterwards. So, let's start at the beginning. As a lawyer, I think about ownership in 3 different ways. I think about these 3 things. I think about physical title, I think about copyright, and I think about moral rights. Let's imagine a simple painting, nothing to do with artificial intelligence, a painting on canvas. Physical title, what do I mean? I mean, if I want to sell you the painting, I take the canvas off the wall and I hand the painting to you and I transfer to you legal title in that canvas and the artwork on it. That's easy. We can all picture that. What do I mean by copyright? I mean it's the economic right of the author to exploit the commercial value of that work. I mean it enables the artist to prevent somebody from copying that drawing. That's what gives the painting commercial value. Again, it's easy to envisage that in a typical painting on a canvas. You can't copy it, you can't create prints of it, you can't create postcards of it, you can't put it on a t-shirt without the artist's permission. That's what copyright means. And regularly, when you buy a traditional painting, you don't acquire the copyright. Actually, that often remains with the artist. Moral rights. Moral rights are this really weird thing that gives the author some protection about his honor and reputation in the artwork. It enables them to prevent derogatory treatment of the work. So if, for example, you were to take a sculpture and put it in a politically sensitive environment, you might be treating that sculpture in a derogatory way. And the artist could prevent that through their moral rights. So when I'm talking as a lawyer, these are the three things I'm thinking about. And I'm going to just look at those in the context of art created by artificial intelligence. It's important to remember, however, that in relation to the same artwork, these three things can be owned by three different people. Okay? I can sell you the canvas, but I, as the artist, retain the copyright, and I retain the moral rights. I might then sell my copyright to a commercializing company to create prints, to create postcards, to create t-shirts. And in that instance, each of these things are owned by separate people, and that's where it gets really fun. Okay, so let's talk about art created by artificial intelligence. My two previous speakers have done a fantastic job of giving you great examples of the sorts of things we're talking about here. But let's imagine that we're talking about acquiring artificial intelligence art. What is it that you need to buy to acquire this? And the previous speaker did a fantastic job with Maria Klingerman's videos and talking about memories of a passerby. There's lots of different bits that you need to acquire. You saw the two screens with the male and the female faces on. You saw the computer, the neural network in the box. And you need to acquire each of these things in order to acquire the artwork. There's also questions about quite what you acquire in relation to the algorithm, and I'm going to come on to speak about that. We can contrast that with what is quite a controversial subject in the artificial intelligence world at the moment, which is another work that was sold at auction called Portrait of Edmund de Bellamy. Unfortunately, I haven't got an image of it for you. What happened here was an adversarial network was used to generate an image which looked a bit like an old master. That image was printed. In the bottom right-hand corner, where the artist might often sign, instead was printed the algorithm. It was put in a nice frame, and it was sold at auction for $432,000. And the question is, how would you acquire that? Well, it's actually much easier, isn't it? You just acquire the printout. You acquire the printout from the artificial network. So when you're thinking about acquiring AI art, there's so many different types there that you have to be quite careful about thinking how and what you're going to acquire, ranging from quite a simple static image to quite a complicated network with computer and algorithm involved. And one of those three things I started with, physical title, copyright. Let's talk about copyright. First of all, whether it even exists in this type of art, and secondly, if it does, who owns it? And there's three different things to consider here. There's the output art, that's the image that's generated at the end. There's the input data, that's the vast number of images that Jake is training his neural networks on. And then there's the network, the software itself, the clever algorithm that learns and generates images. Let's look at each of those in turn and think about whether copyright exists in these. And while we're doing that, let's remember what copyright is there to do. Philosophically, copyright is a reward. You spend time slaving over your art. You have judgment, you have taste, you have skill, and you pour your intellectual creativity into artwork, and you are rewarded with copyright. It prevents others from taking your creativity by copying what you've created. So if these things are to be rewarded with copyright, from a philosophical perspective, many people would say there has to be intellectual creativity that's been poured into these three things to justify copyright being rewarded to you, to justify your labour. So we heard Mario Klingemann in his talk talking about the fact that the computer generates things, but obviously it needs a human being as well. So one of the questions is, could the computer be the owner of the copyright in these types of works? Well, we haven't always got helpful answers in the law, so we have to look for similar analogies. And this case, which was considered in America, talks about whether a non-human can own copyright. This is Naruto. He's a monkey, in case you can't tell. And Naruto took a selfie of himself. He took a selfie of himself with the camera of a photographer called John Slater. John was photographing monkeys. He left his camera unattended, and Naruto took a photograph of himself. I actually think it's quite a good photo. I'd be pleased if I took that. So the general rule is that copyright is owned by whoever is the author. Well, who was the author of this photograph? Naruto was. So does Naruto own the copyright in his selfie? The US courts struggled with this. It had to go all the way to the Court of Appeal. And the reason they were even considering the question is that David Slater, the photographer, published a book of these photographs, and PETA, the people for the ethical treatment of animals, sued David Slater, alleging that he had infringed Naruto's copyright. That's why the case was in court. It went to the Court of Appeal. The Court of Appeal said, don't think monkeys can own copyright. And so, unfortunately, the US position is only human beings can own copyright. That's the US position. So poor Naruto doesn't own the copyright. So we haven't managed to answer the question about whether non-humans can own copyright. We know monkeys can't. What about computers? Well, in the UK, back in 1985, when computers were not what they are now, there was this case decided by Judge Whitford. And this was a case between two newspaper companies who generated a prize. And to complete the prize, you had to fill in a grid of letters. And what they were arguing about is who owned this grid system. And they, Express newspaper said that the Liverpool Daily Post had copied their grid of letters, and this was outrageous, and it was copyright infringement. And Judge Whitford was asked to decide whether this grid of letters, which was all generated by a computer, whether it was a copyright work. And Judge Whitford thought it was a copyright work. And he said the computer was no more than a tool. It's as unrealistic as it would be to suggest that if you write your work with a pen, it's the pen which is the author of the work, rather than the person who drives the pen. Seems fairly logical, doesn't it? You wouldn't say if you're a painter that the work had been created by the paintbrush, you held it, you directed it. The problem was that back then in 1985, computers were not as clever as they are now, and programmers like Jake and others weren't as clever as they are now. And so now we have computers that are doing things without as much human input. They're generating their own algorithms, they're generating their own images. Does that mean that the computers now are more than just a tool? Have we moved out of Judge Whitford's world into a more complicated world where computers might actually be doing things without the humans? So the philosophers have had a go at this. They're even worse than the lawyers. Ronald Dworkin, who's a well-known philosopher, he thinks it's the programmer that undertakes all the creative stuff here. But this lovely lady at Stanford Law School thinks it's questionable to award authorship to the programmer, so the philosophers can't agree. We know the US Copyright Office has said they won't grant copyright to works produced by machine, but they've added this bit on the end. They won't grant copyright to works produced by machine which have had no creative input or intervention from a human author. So if there's a bit of intervention from a human author, we can get some copyright. But why do we care? Why do we care whether copyright subsists in any of these things? Well, the business world cares, because in order to generate value from these things, you need to stop other people from doing what you've created. You need to stop copying. So if there's no copyright in these works, other people are free to use them, free to copy them, and that means it's quite hard to create a business world around them. So it reduces incentivization to create. It also reduces or makes it harder to get financial investment. So that's one reason why copyright is important. And I'll give you an example of this, and somebody who does think it's very important. There's a man called Elgamal who has created an adversarial network and created a company to look after this adversarial network called ArtRendix. And he thinks that he can derive a lot of value from his neural network. For example, he thinks he could use it to help with provenance authentication. He's got a whole bank of data telling him whether something looks like a real flower, a real sun, a real image. He thinks, well, I could use this to help in authentication disputes. I could sell that. That's a valuable tool. I could use it to predict what's going to be the next best thing in the art world. I could use it to catalog images. I could use it to create cheap commercial artwork for hotels. Right? And a venture capital trust agreed with him, and they've given him $2.5 million to develop that. But the point is, if he hasn't got any copyright in it, so everybody else can use it, the venture capital isn't going to invest $2.5 million in it. That's why, one of the cynical, lawyerly business reasons why copyright's important. So what are we going to do? Are we going to say these works can't be protected by copyright at all? Are we going to say they can be protected by copyright and copyright's going to be owned by the programmer? Or are we going to say copyright can be owned by the person who actually uses the software? How are we going to define this? Well, in the UK, our parliament is being particularly rubbish at the moment. But back in 1988, they were doing better because they put this really useful provision in the UK copyright law. And they foresaw this problem, that we might struggle to find a human author. And they said, look, we're going to define these things called computer-generated works. That's something that's generated by a computer in circumstances such that there is no human author of the work. So this is the extreme end of the spectrum. No humans involved, just the computer. And they said, but we're going to find a human author, because we know copyright can only be owned by humans, not monkeys. We need to find a human author. Who is it going to be? The author is going to be the person by whom the arrangements necessary for the creation of the work are undertaken. Clear, right? We all know who that is, do we? Who is it in Jake or Mario Klingeman's or whoever else's artificial intelligence art? Who is it who by whom the arrangements are necessary for the creation of the work are undertaken? Well, it's interesting because this is the same language that's used in our UK law about producers of films. Exactly the same language. So when you're trying to work out who produced a film, that's the same test. So it gives us a bit of a clue as to the types of things that people might be looking for. And it's interesting, right, because if you fall within this, as opposed to a human author, you get a different duration of copyright, right? If you have a computer-generated work, your copyright lasts for 50 years from the year of creation. If you've got a human author, lasts for 70 years from the death of the author. It's quite a big difference in terms of copyright duration, quite a big difference for the commercial world to think about. But it solves the problem of not having any copyright or any author at all. So it's trying to recognize the work that goes into, all that work that goes into creating the art. But it still doesn't really totally answer the question about who it is in those scenarios that is the person undertaking the arrangements. So, we see various suggestions, but obviously there's a lot of work that goes into choosing the input data. Is that the author? Is it the person who writes the algorithm? Is it the person who trains the algorithm to be really clever at spotting the flowers or the trees or the birds? But at least we've got something to hang our hat on here. Okay, I'm going to move on quite quickly. We talked about output data, which I think is the output art, which I think is perhaps the most interesting thing. But there's also a question about the algorithm itself. What about copyrighting the algorithm itself? Bit of debate around the world, about whether copyright can exist just in a mathematical formula. But certainly, good consensus that the software itself is a copyright work. And the interesting thing, if you're an artist in this field, to remember, whoever writes the ones and the noughts, whoever writes the code, owns it, unless you have a contract with them. So if you're a brilliant artist but not a brilliant programmer, and you get your programming mate to write the code for you, he owns the code unless he signs a contract with you. Remember that, because otherwise you don't own your algorithm. And if you don't own the algorithm, you might have a license of it, but who knows what the terms of that are. So the other interesting thing is, if you're going to buy some of this art, let's imagine you buy Maria Klingemann's Memories of a Passerby. You've bought the box with the brain in it. It's creating beautiful artwork. You probably don't own, I don't know the answer to this, somebody in the audience might well be able to tell me, you probably don't own the software itself. Tomorrow, Mr. Klingemann can go and make another machine with the same software on it. Yeah? And that's his creative endeavor. In the same way that, and I don't want to trivialize his artwork, but it's a useful analogy for people like me who are less good with art. In the same way, when you go and buy Microsoft Word, you don't buy the whole Microsoft Word so nobody else can use it. You just buy a license of it. So tomorrow they can sell another one, and another one, and another one, and another one. So if you don't own the copyright in the software, it doesn't give you sort of exclusivity in the algorithm. It gives you beautiful artwork for you to enjoy. But Maria can go on and use that algorithm on different data sets to create more artwork. I've just picked a couple of, well, 4 actually, examples of software that are being used in the AI art world at the moment. The interesting thing to look at here is 2 of these are free for anybody to use, called open source. Anybody can use them, generate what they want with them. Great stuff. 2 of these are being kept confidential in terms of the actual code, and it's more tightly restricted. So Deep Dream, which Jake gave us some lovely examples of, Google engineer developed it, shared online, anybody can use it. Same with something called processing, code which other people can use. Here's the controversial bit behind the portrait which I mentioned, sold at auction for a lot of money. The neural network there was originally available publicly online, written by Robbie Barrett, originally shared freely on the web. And when this portrait was created, Portrait of Edmund de Bellamy, it wasn't created by Robbie Barrett, it was created by a collective called Obvious, who used that network to generate the image that was then sold at auction. They didn't write the network, they didn't choose the input data, they didn't train the algorithm, but they sold the work for $432,000. Legally, I've got no problem with that. Morally and ethically, in terms of who generated the underlying substance of that and who made it possible, that's another debate. And that's something which I know lots of people in the room will have strong views on. So Robbie Barrett later changed the terms of that license to that software so that it's not freely available anymore. So that's the software. Also need to think about copyrighting the input data. Lots of these things have been trained on old masters for a good reason. No copyright in them. Not a problem with copyright infringement, but something to think about. Moral rights, these weird things I was talking about preventing people from using your work in a derogatory fashion, exempted for computer-generated works. There aren't any. You can't have them. The reason being, it's all about rewarding human endeavour, protecting your own reputation, and if the computer has generated it, there's no reputation to protect, is there? So no moral rights for computer-generated works. And my last slide. Here's some tricky brain teasers from what we've just been talking about. Let's look at renovating or altering AI art. Right, just quickly have a quick look at these. What about if the art develops a bug? My computer's rubbish, I don't know about yours. I turn it on and it goes, error 103, can't load this, can't load that, can't use the printer. What about if one of these AI arts develops a bug? Can you fix it, or is that copyright infringement? Thankfully, the software directive gives us a clue, and it does enable us to fix bugs. But what about if I really love the algorithm? I think it's great, but I'm getting a bit tired of the old master theme. I want a different input data set. Can I use the algorithm with a different input data? Today I want some flowers. Can I use the algorithm instead? Don't know. Don't know the answer. What about exclusivity of the work? We've just talked a bit about that. And then interesting, the point which the previous speaker picked up on at the end about renovating and hardware becoming defunct or obsolete. Thankfully, the copyright law helps us with that. You're allowed to load programs onto new machines without infringing. So, all sorts of questions coming up. But that hopefully gives you a bit of a flavour, something to think about over the drinks.
Thank you very much, Alejandra. Muchísimas gracias a todos nuestros ponentes por compartir.
Thank you very much to our speakers for sharing their experience with us and for presenting a topic which may be too complex and technical at times. We want to open the floor for questions. We have 10 minutes. I would like to invite our speakers to the stage so that you can answer their questions, but we just have 10 minutes.
Now.
Like in Spanish.
Tenemos micrófonos.
Do we have microphones? We have microphones on the right and on the left.
Sí, tenemos una pregunta.
We have a question there. Is there a mic? May I ask? This is for Alexandra. I'm the manager of the Poetry Festival of Madrid. We are generating what we call a poetic golem. We are doing AI with poetry. And we wondered something, that the texts that are being used to feed the golem, is there somehow an infringement of moral rights if you use text by authors with rights? If the poem that generates the golem, the poem generated by the golem, if it's based on poems by authors with copyrights, is there an infringement?
And I would love to be able to give you a simple answer. The answer in America is probably, if you're end poem is very different from your input data, you're probably okay. That's probably the answer in America, where they have this thing called fair use. So if your output poem is sufficiently different from your input poem, you're probably okay in America. In Europe, we don't have fair use, not in the same way. And in Europe, merely uploading the poems to the computer, copying them onto the computer database, may in itself constitute infringement, if your poems are still within copyright. So don't forget, if you choose Wordsworth and others, you're okay. Good idea. So old poems are a good idea. New poems, it's difficult to justify. It's difficult, particularly in Europe. We can talk more, but it's not what people want to hear. But copying in any form, including onto the computer hardware, is infringement, unless you have some special exception. And artwork is not an exception.
Tenemos otra pregunta aquí.
We have another question here. Good afternoon. Thank you very much. It was a true pleasure listening to your three presentations. My question is from Mun-Jung. I'm a mathematician. I've always worked as an artist, and I'm working with big data now. And I would like to know whether Mario, all his programming in Python or whatever, if he is familiar with these tools, if he can use them, or did you in Onkaos help him with the programming or technological side of it? When you say programming, what do you mean? Training the model, etc. Mario's case, you know that he's widely known at international level because he's a pioneer in AI, but the tools he works with, he owns them. So I don't know what you think, Jake, but in Mario's case, it's his tools, and we support him in a different way. He doesn't work with a team. No one programs for him or helps him to do anything. That's something very particular of Mario. There are some artists that, you know, work even outside the field of new technologies with the team in the workshop. But it's not Mario's case. Everything you've seen by Mario, it's extraordinary. Because of this particular reason, because he does it himself.
Also, it gets more complicated as well, because I guess, as you know, if you're from this background, all of these are built on libraries which are built by teams of programmers. So when you say Mario has written the code, it's like maybe he's written the top level of code, but there are so many levels underneath that. And I think programming is inherently such a collaborative thing. And I think maybe that's where I had issues as well with some of these copyright issues around who owns the algorithm, is that, sure, Mario has kind of written in TensorFlow maybe, or a programming language, kind of his implementation of something, but then he's written that by looking at a research paper, maybe from someone from Stanford who kind of came up with this model architecture. And then he's also using programming languages which imports the work from so many other individuals. So it's very hard to pinpoint, you know, exactly. But I think Mario is a rare instance that he is unbelievably technically gifted. I try to understand as much of the code as possible as well, and I think that's important for me as part of the process. But I do know also there are many artists who do have a team of engineers that create the work effectively for them. So.
Bueno, Mario se podría apoyar.
Well, Mario could use the support of a team, of a big team. The support, the journey of working with innovation and AI with Onkaos and Mario. It takes place because we support in different aspects he doesn't know about. For example, legal issues, transportation, the autonomous machine you've seen in Memories of Passerby, we helped him to produce it in Spain. But I think that in Mario's case, the situation is interesting because in painting you have an idea, you execute it, you show it, you exhibit it, and that's okay. But in new technologies, it's interesting seeing the whole process. If you know how you use the new technologies, how it was the machine, the one that created what you wanted, that journey is also valid for me. In Mario's case, his conceptualization is highly linked to new technologies. These are his tools. And while we support him, and while he thinks in the next explorations, at conceptualization level, he works by himself.
Hoy.
¿Tenemos otra pregunta?
We have another question.
Hemos oído hablar.
We heard a lot about money, about copyright, about individual rights on certain piece of art, but more than a question is just a reflection based on what you, Alexandra, mostly has mentioned. But it is for the three of you. If we conceive capitalism as a system that is not natural and that will die at some point, what will be the role of art in some other type of society where moral rights are preserved, but art can be understood not as something which is purely and exclusively economic in nature, but something that is in the field of creation, freedom, imagination, and that even goes beyond the individual and can even take us, and we have seen several examples here, to art in a much more collective sense of the word, in a creation that goes beyond a single individual, because there is a combination of efforts from the person that creates a software, the programmer, the person that executes the piece of art, and the people who live and experience art as an interactive kind of thing, as you mentioned in the round table. So this is not so much a question, but perhaps capitalism will die at some point, sooner or later, and copyright will also die. I'm also a lawyer, and we lawyers have more and more problems to be able to defend the author's right as an economic right. One thing is moral rights, and something different is the copyright. And the copyright, I think, is going to disappear. However, or many organizations want it to be kept, but I think that a huge space and room will be open for socialization of art and culture as a collective creation, and as something that should be within the reach of all and each and every one of us. And I have hopes that art is not just money. Money will die, and art will be kept in a different types of society before we commit suicide as a humankind, or before capitalism puts an end to humankind.
Tenemos tiempo para una pregunta más. Así.
We have time for another question, just one question.
Sí.
Buenas noches. Mi nombre es Agustín, soy de Buenos Aires.
Good afternoon. I'm Agustin, a designer, a photographer, an editor. I'm very interested in the field of printing, because from an economic perspective, I as a printer, an editor, I'm interested in that. But in Sotheby's, what did the buyer take home? He took a print that is just part of this. That is the outcome of a whole process. Was there a human being that decided that that was going to be printed and that was going to be sold? Was there a human, for American law, that it would be covered because there was human intervention in that part? That is my question. Thank you.
I think that's a really important point that you're making. I think this is actually where some of the controversy has come from as well. aside from the controversy of who owned the rights and the algorithm, I think, like you said, it's a human that inputted the data. It was a human that trained the model, and it was a human that selected the output in the end. It was obvious. They chose, this is the one they wanted to print. And I think that's kind of a key fact. And in a way, I think a lot of people, including myself and Mario, we've been speaking about this, got frustrated that there's this sort of level of mystification in a way by saying, like, the machine is creating this. You know, I think that's a really important point to make. But then there's also, yeah, of course, the copyright side of that. But I guess, yeah, there is the intentionality of the human, I guess.
Yeah. I mean, to answer the factual question, there was an art collective of three people, and the art collective was called Obvious.
In Paris. They
selected the image that was to be printed, and they were the ones that put the image up for auction. But as Jake says, they didn't write the algorithm, train the algorithm, or choose the input data.
Well, it's more than that. They claimed that a computer had done all of those things autonomously, completely autonomously from them. And I think it's really important that at this stage, it's still a complete collaboration between the human and the computer. Because otherwise, if we claim that, it leads to fear-mongering. It's saying, computers capable of doing this autonomous art thing, oh shit, it must be capable of a whole lot more as well.
It's really interesting, actually, for those who are interested in this debate. I think that I'm not a big user of Twitter because I'm old-fashioned and a lawyer, but there's some really good stuff on Twitter that explores this debate, isn't there? And there was actually a debate between Robbie Barrett and Obvious on Twitter about what happened, and I think somewhere I wrote down Robbie Barrett's quote, which I thought was quite good. Am I crazy for thinking that they, Obvious, really just used my network and are selling the results? That was Robbie Barrett's sort of summary on Twitter to Obvious. Yeah. And to be fair, I guess Obvious did ask for consent, but he had no idea that what they were going to do was sell at auction a work for that sort of magnitude of money. So a really interesting sort of ethical and moral debate around how to use these things. But the Twitter feed on this sort of stuff generally is really good, isn't it?
Yeah.
Sort of looking at new avenues of artificial intelligence and the debate around the philosophy and the ethics of it.
But it is a really exciting time. I mean, that's not to be forgotten. I think that's the thing, We've just got to be a bit careful of not overstating it as well, because there are few people that really understand exactly how these tools are working. I mean, even the engineers don't fully understand. So there is obviously something quite mysterious about it. But yeah, no, I think it's really exciting. And Obvious was kind of a catalyst, I guess, to discuss a lot of these issues in the art market.
It's true that there are still lots of problems to be solved. And the world is huge, and technology is a vast field. But there's also the art market with collectors that don't just buy for investment purposes. They're collectors who are passionate about owning an object in their collection. And our job is also to think about it and to work about it. That's why we're agents in the art market. But the market will always be there. And I think that a way to promote the works of artists is by creating collections and creating objects for collections, and that has to be physical. I think we're behind schedule. Thank you very much for your questions, for your participation. I hope this was a fruitful debate for all of you.